Hello, marvelous mathematicians. Today we are working on Lesson 32, Session 3. We are going to develop finding same area with different perimeter. So we're going to talk about some shapes, some rectangles today that have the same area, but the perimeter is different. Now, just to kind of remind ourselves where we're at, we've been talking about two different math words. Our first word is area. Area is the space covered by a shape. So remember our rectangle, the space inside the rectangle is what we call the area. Same with our combined rectangle, the space inside is called the area. And even with a triangle, the space that fills up inside a triangle is called the area. We find area of a rectangle by multiplying length times width. Then we talked about perimeter. Perimeter is the distance around a shape. Remember the soccer field. If we started in one corner and we walked around the outside edge of the soccer field, then we would be looking at the perimeter. Remember, to find perimeter, we add all the lengths. So if I start in one corner, I have to add the length, then the width, and then the bottom length, and then the side length. And we would add all four together to find perimeter. If we're looking at a triangle, remember, we would start at one vertex and we would walk along the outer edge and add all the lengths to find the perimeter. Okay, so let's go ahead and use that information for today's lesson. We are going to start with read and try to solve the problem below. And I like the word that they use, try, because they're giving us something hard today and we want to see what we can do. Emma drew a rectangle shown. Okay, everyone take a look at the rectangle. Where's our rectangle? There's our rectangle. What other rectangles have the same area but different perimeters? That's something new. Let's go ahead and read it again. Emma drew the rectangle shown. What do we know about this rectangle? Yes, it is a square. It's a rectangle and a square. What do we notice about the length of it? 1, 2, 3, 4. It has a length of 4. Now, what about its width? What is the width of our rectangle? It is also 4. That's why it's a square. Okay, now what are they asking us? What other rectangles have the same area? Other rectangles that have the same area, but different perimeters. Okay, same area, different perimeters. Now that means they want us to find other rectangles. That means they don't want us to use this rectangle. They want us to make a different one, but they gave us some rules. In order to make the new rectangle, that has to have the same area. Do you know what area we have? Well, we could find out. But we also have to have a different perimeter. Do we know the perimeter right now? No, but we could figure that out. So in order for us to draw other rectangles, we need to know what the area is and what the perimeter is. Now, I would like for you to try this on your own. Go ahead and pause the video and see if you can figure out what is the area, what is the perimeter, and can you draw another rectangle? Okay, if you are going to give this a shot, pause the video and come back when you're done. Okay, so as you were working this out, what did you find out? What is the area of our rectangle here? Remember, area is length times width. What is the length? What is the width? We've got 4 times 4. And 4 times 4 tells us that the area is 16 square units. Okay, so we know our area is 16 square units. What is the perimeter? See, we have to draw a rectangle that has a different perimeter, so it can't have the same perimeter as this one. How do we find perimeter? Remember, we find perimeter by adding all the sides. How many sides do we have? That's right, we have 4. So remember, we're going to write first side, another side, 2, 3, and 4. We have 4 sides. I was going to add another one. Okay, 1, 2, 3, 4. Now, what is the length of my first side? So remember, we start at one side and we just walk. This one's 4. Then I have to walk to this corner. And how much was that? 4. Then I walk to this corner. 4. And then I have to go back to where I started from. And another 4. What is 4 plus 4 plus 4 plus 4? That's interesting. Our perimeter is also 16 units. Now I'm going to tell you that doesn't always happen. Sometimes it does, sometimes it doesn't. Okay, so now what do we know we have to do? Zoom in a little bit for you here. Now we have to build another rectangle. Another rectangle that has to have 16 square units. Now, to do 16 square units, it'd be fun if we had little blocks, but we don't have blocks, so I'm going to use some grid paper. If my area equals 16 square units, what would we have to do? Because remember, we are going to be multiplying. Remember, area is the same thing as length times the width. So for our area here, what did we multiply to get by 16? We multiplied 4 times 4. What's another way that we can find 16? It is also 1 times 16. Is there another way to find 16? There is 2 times 8. So 2 and 8, 1 and 16, and 4 are all factors of 16. So we had already had a rectangle, or sorry, a square, a rectangle, that's a 4 by 4. Could we draw a rectangle that's a 1 by 16? We could. Can we draw one that's a 2 by 8? We could. So we could try 2 different types of rectangles. We could, well, we've got to count 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I could make this long, skinny rectangle. Okay, do you see that? Long, skinny rectangle. Okay, I actually, you know what, if I talk about it, I actually drew a 16 by 1. But remember, commutative property allows me to do that. Now, is it 16 units? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It is 16 units. Square units as far as its area. Now, can I draw a 2 by 8? I can. Let's find. So let's do 2. 1, 2. Now, how many down do I have to go? What's my width? 1, 2, 3, 4, 5, 6, 7, 8. Did we get that all on the camera? There we go. Okay, so here's our big rectangle. And does our rectangle have 16 square units? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It does. So now I have drawn 2 other rectangles that have an area of 16. Now, if they have an area of 16, what is their perimeter? Let's look at that. Let's see if this one, what was the length here? That was 8. And this is 2. What's the length of this side? It is also 8. And what about this side? It's also 2. So now this has a perimeter of what? What is our perimeter? Let's pull it over here. So if I have a 2 by 8, has an area of 16, right? This is my new rectangle, and I can even sketch it here. Right, there's my 2. Okay, my 2 by 8. And the perimeter is going to be, well, we've got 4 sides. And we've got 8 plus 2 plus another 8 plus another 2. And together that equals, what's 8 plus 2 plus 8 plus 2? We've got a perimeter of 20. Is that different than this rectangle? It is. Remember, this one has a perimeter of 16. And this one has a perimeter of 20. So even though the area is the same, there are 16 squares. My perimeter is 20. Here my area is 16 squares, but my perimeter is 16. That's interesting. Let's see what else we're going to do. Go ahead and turn to page 722. Okay, we're going to explore different ways to understand finding rectangles with the same area and different perimeters. It's the same rectangle that Emma drew. Remember, it's a 4 by 4. And if we remember, area was 16 and the perimeter was 16. Except this was 16 square units and the perimeter was just 16 units. Okay, so first thing you can do is picture it, which is kind of what we did on our graph paper. You can use drawings to help you find rectangles with the same area and different perimeters. The area of Emma's rectangle is 16 square units. Below are two other rectangles that also have an area of 16 units. The same thing that we drew on our grid paper. You can also turn these rectangles on their sides to get two more rectangles, which is kind of what we did here. If we take our grid paper, see, mine was a 8 by 2. You could turn it this way, and it's an 8 by 2. Okay, you can also model it. You can use a table to find rectangles with the same area and different perimeters. You can make a table showing the measurements of rectangles that have an area of 16 units. The rectangle Emma drew is circled. That's kind of like we did. Up here, we made a chart too. We knew that an area of 16 is a 4 by 4. A 16 area could also be a 1 times 16, and an area of 16 can also be 2 times 8. Do you see those in here? They are 16 times 1, 8 times 2, and 4 by 4. This is the one that Emma used. And when we did our work over here, remember we did the 2 by 8. So this is the one we did. Oops, sorry, you can't see. This is the one we made. This is the one Emma made. Okay, let's go ahead and see what we can do with that information. Now we're going to connect it. Now you will use the problem from the previous page to help you understand how to find rectangles with the same area and different perimeters. Look at Picture It. How can you tell the two rectangles shown have the same area as Emma's rectangle? How can we tell? What could we do? Well, we could go area equals length times width, or we could count, right? We could have just counted our squares, which is what we did on our grid paper. So there's two ways to do this. We could count the squares to make sure that the areas are the same, or we could also use the equation. Both of them will help us figure out that the areas are the same. Okay, number 2. To find other rectangles with an area of 16 units, think of multiplication facts with a product of 16. What are the multiplication facts that have a product of 16? So if we wanted to find 16, what do we need to multiply? We could multiply 1 times 16, and we could multiply 2 times 8. We could also multiply 4 times 4. Could I multiply 16 times 1? Yeah, I could, even though it's the same. Commutative property shows me that both of those are 16. And that also means I could do 8 times 2. So these are all multiplication facts that have a product of 16, and that will help us to find other rectangles. Now look at the table and model it. Look at the table again. See the table? And we made a table too. Ours looks a little different, but it's still a table. Where do you see the factors and products of the multiplication facts you wrote? Okay, what were the factors? Let's go back and see. When we did 16 times 1 to get an area of 16, What are 16 and 1? They are the length and the width. Notice that? In our 4 by 4, it's the length and the width. So our factors are the lengths of the rectangle and the widths of the rectangle. What is the product? Remember, factors, maybe I need to remind you, if I have a 2 times 8 equals 16, these two are factors. Remember that? These are called factors, and if you have to say factors, 2 and 8 are factors. 16 is our product. That is the solution or the answer to our multiplication problem. So just in case you forgot that, if you need to, write that down. So when we are looking at area, the factors are the lengths and the widths. What is the product? What do we call that? When we find 16, what did we just find? We found the area. So the products are the length and the width, and the product is the, did I say that wrong? The factors are length and width. The product is the area. Okay, number 3. How can 2 rectangles have the same area but have different perimeters? How can that happen? Remember that in order to have the same area, so 2 lengths are, miswrote that. To have 2 rectangles, 2 lengths are multiplied to find the area, but when added to find perimeter, they are different. And we'll do a couple practice ones so you guys can see this. So even though we use 2 times 8 to get 16, you can also use 4 times 4 to get to 16. But when we use the factors to find the perimeter, the length and the width to find perimeter, they give us different perimeters. So let's go ahead and reflect and think back. What method did you like using? Did you like to draw models and count? Which is what we kind of did here. We drew models and we counted. Or we used our math facts. See how we used math facts up here? Or you can also make a table, kind of like they did a table here. Which method do you like to use to find rectangles with the same area but different perimeters? Go ahead and write down what you like to do. When you're done, turn the page. Okay, let's look at the apply it. Use what you just learned to solve these problems. Look at the rectangle shown. What do you notice about the rectangle? How long is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9 units long. What do you notice about its width? It's 2 units. Draw a rectangle that has the same area but a different perimeter. Show your work. Okay, so it has the same area. First of all, in order to do this, remember we have to find the area first. Right? We looked at the rectangle. We have to draw a rectangle that has the same area. So we need to know the area. What is the area of this? Remember, 2 times 9 is 18. So our area is 18. So we're going to have to draw another rectangle that has an area of 18. So what do we need to know? So remember they said we can make a table. If area equals 18, what are other numbers that multiply to make 18? We could find that the area is, well, they gave us 2 times 9. Could we do 1 times 18? We could. To get 18, could we do 2 times 9? Well, that's the one they gave us. What's another way to say 18? Think about your math facts. We could also make an 18 by going 3 times 6. Are there any others? Nope, there's no others. Okay, so now we can make another rectangle that has either 1 times 18 or 3 times 6. Which one do you want to make? I think I'm going to make the 3 by 6. So I'm going to go ahead and sketch it. Now I have to cut things in thirds. Just do the best that you can. Okay, and this one's got to be 6. Okay, there we go. So now I have 3 as one of my lengths and 6 as my other one. Now, what is the perimeter? We've got to now check. Our areas are the same, right? If I counted all my squares, how many would I get? 18. If I counted all my squares, how many would I get? 18. Now we have to make sure that they have different perimeters. Okay, what is the perimeter of our first rectangle? Well, how many sides are there? There's 4. 1, 2, 3, 4. Now remember, we can look at this. We have a 9. We have a 2. Remember, we're walking all the way around. What would this one be? That's also 9. And then this one is 2. So what is our perimeter? 9 plus 2. 9 plus 2. We have a perimeter of 22. Now we've got to make sure that this one is not a perimeter of 22. So how do we find this perimeter? Remember, we've got how many sides? 4 sides. What's my first side? 6. What's my second length? 3. What's the length up here? 6. And what's the length here? 3. So what's my perimeter? 6 plus 3 is 9. And this is a 6 plus 3 is 9. And 9 plus 9 is 18. Okay, do we have different perimeters? We do. So this area is 18, right? I think we have a big 18 here. And this has an area of 18. But the blue rectangle has a perimeter of 22, while ours has a perimeter of 18. So did we do this correctly? Did we draw a rectangle that has the same area, 18, and a different perimeter? Yep, we did. Okay, so number 6. Look at the rectangle you drew for problem 5. Is its perimeter the same as, greater than, or less than the perimeter of the original rectangle? Okay, so let's look at our new rectangle. Has a perimeter of what? 18. What about our original rectangle? What's our original rectangle? It was 22. Is 18 the same as, which we would say equal to, greater than, or less than? Which sign are we going to use? 18 is less than 22. 18 means it's smaller than 22. So we're going to say less than. Okay, and our last one, number 7. Joel plans to start a rectangular garden like the one shown. He wants to put fencing around his garden, but has only 20 feet of fencing. Use the same area as this garden. What side lengths could his garden have so it has a perimeter of 20 feet? Show your work. There's a lot there. Let's read it a second time. What's this about first? It's about Joel, and what's he doing? He's building a garden. He wants a rectangular garden, just like the one shown here. Okay, let's read it again and see what information we have. Joel plans to start a rectangular garden like the one shown. He wants to put fencing around his garden. Okay, so he wants to put fencing right around the garden. Right? Fencing. but has only 20 feet of fencing. He has only 20 feet of fencing. Using the same area as this garden, what side lengths could his garden have so it has a perimeter of 20 feet? Show your work. Okay, so what do we know? He has 20 feet of fencing. What else do we know? He wants the same area, right? He wants the same area as this garden. What do we know about this garden? We know that the garden is a 3x8. What is the area? 3 times 8 equals the area, which is equal to what number? 24. So we know that the area is 24. I'm going to actually put that information. That's what we need to know, right? We figured that out. We know that our garden is a 3x8. So we need to know what the area is. And you guys just helped me. We figured out that 3 times 8 is 24. So we have to create. What do we have to create? Let's read the question again. Using the same area as this garden, what side lengths could his garden have so it has a perimeter of 20 feet? So what do we need to know? We need to know its new perimeter, right? And it has to be, perimeter has to be 20. So it has to have an area of 24, but a perimeter of 20. Let's see, does this have a perimeter of 20? If this is 3 and this is 8, what is this? It's 3. What about this one? It's 8. What is 3 plus 8 plus 3 plus 8? 3 plus 8 plus 3 plus 8. We've got 11 and 11. That's 22. So this garden has a perimeter that is too large. It's 22. We need it to be 20. So let's look at what numbers go into 24. If we know the area has to be 24, remember how they used a chart? What's over here? So if my area has to be 24, how else can I make 24? They did 3 times 8, but that's not going to work for us. That's not going to work. What else can we go? Could we do a 1 by 24? We could. What else can we do? We can do a 2 by 12. What else goes into 24? We've got 3 times 8. What about 4? Does 4 go into 24? It does. 4 times 6. Okay, which one of these is going to have a perimeter of 20? Okay, so let's think here. A 1 by 24. Is that going to be 20? I don't even have to add that one, so that one's not going to work either. How about a 2 by 12? I have 2 here, 12, 2, and 12. Is that going to equal 20 going around? Nope, that's too big. How about the 4 by 6? I have a 4 and a 6 and a 4 and a 6. If I add 4 plus 6, I get 10, and 4 and 6 is 10. So 10 plus 10 is 20. My perimeter is 20. So this one works. It's kind of like I'm making a table and checking. Okay, this was a long lesson. I have to tell you guys, if it ever gets long, you can pause for a little bit, take a break, and then come back. But now that you're getting ready for 4th grade, some of our word problems are going to start getting much more challenging. So thank you for persevering with me today. Okay, it is time for you to start your practice, the one that you're going to work on your own. And then you can come back and get some answers from me. I was going to show it to you, but I think I already have it set aside. So work on your green sheet on page 725 and come back and we'll work on it together.